Good morning, everybody. We will get started in 2 minutes. 2 minutes. Well, good morning there, everybody. We are very excited to welcome you to our SC Aerospace Partner Webinar, Blockchain Technology and Network Confidence. My name is Stephen Astaborski. I'm the Director at SC Aerospace, part of the South Carolina Council on Competitiveness. And this is our next webinar where we bring on one of our partner companies and have them present on a topic that they focus on in their work, and hopefully you all are able to learn a little bit about our partner company and hopefully identify a place where you may be able to do some work with them or collaborate to grow your business and meet your customers' needs. A few reminders before we get started. As with all of our partner webinars, we will be recording this and we'll be posting it to YouTube in the upcoming week. Also, if you have questions, please ask them in the chat as we're going through the presentation, and we can ask them at the end. Or if you just want to hold on to your question until the end, we will have a Q&A session where you can unmute yourself and ask your question. One more reminder before we get started, an upcoming event that SC Aerospace has is our Aerospace Night with the Greenville Drive. This event will be on July 23rd. First pitch will be at 7 p.m. And we are putting together some programming right now to feature the aerospace industry statewide. It will be located in Greenville, but it's not just a Greenville or an upstate focused event. This is focusing on aerospace throughout the whole state and the impact that it has on our economy. If you or your company would like to sponsor SC Aerospace Night with the Greenville Drive, please contact myself via email and we can get you the details. We have a number of sponsors already and are excited to bring in more companies that we can help feature and promote the industry. But with that, I'm going to hand it right over because he's got a lot to talk about. So Rusty, take it away.
All right. Thank you, Stephen. Let me share my screen now and go to the desktop and share. And hopefully we are coming through. So
we got you, Rusty.
Excellent. So yes, real quickly, this is intended to be an educational session for practical use of blockchain. It's one of those things that everybody has a lot of questions about, and we hope to answer a few questions for you. But first, a little bit about me. I've been in supply chain and operations management for roughly 37 years now. It's been quite a ride. You can see I spent about half of my life in aerospace and defense, and I've done it all. You know, I've been a machinist, all of the jobs you can imagine in warehousing, went into scheduling and planning, materials management. I've had purchasing, customer relationship management. The other thing is I've progressed to points in my career where I was actually directing a company where we had 2.3 billion in direct spend, 43,000 appliances being made every day, and 1,500 moves, and I orchestrated from a material standpoint that work. So I have a lot of experience, I guess you would say, in supply chain and operations. And from a personal note, I'm a born and raised South Carolinian. I'm from Edgefield, and I currently reside down in the southern part of the state, down in the Low Country. And I've been with Surgere now for almost 3 years, and I really enjoy it. So the point is, I really do understand the complexities of supply chain and operations. So why blockchain? The thing is, we're not going to talk about cryptocurrency. You can read all you want to read about that in the news these days. Will not be technical in the discussion today. And the other thing is, we're obviously not going to try to exhaust all the uses and use cases for blockchain. But where we're going to try to focus a little bit, if you're ever asking yourself this question, especially in aerospace, do I need proof of authenticity? Do I need to know where a part actually came from, and do I need to prove that? Do I need someone that's trusted, and do I need transparency in the work that's being done so that I can prove that authenticity and I can prove that genealogy? Does the information in my supply and demand network, do I need to share that? Does it need to be seen? And what kind of gains can I make from that? And then, do you need to know what's going on with a part right now? Do you need to look into the supply chain, whether it's back at a supplier, in transit, sitting in a warehouse, or actually picked to go on an aircraft? Those are the kind of questions, you start asking yourself. And if you start going to the affirmative and answering those questions, then, blockchain may be a solution that you need to take a look at. So, common problems that need solutions. Obviously, we need to understand, where did a part originate? Do I need to prove provenance? Were they authorized to perform the work that we actually gave them? And, we're really not talking about supplier quality or certified suppliers. Obviously, you're going to go out and you're going to certify suppliers, and you're going to go out and you're going to have QA approve things that are going on. And you want to make sure that that person that you have doing work can make the part to the type design. But how do you validate that? How do you prove that as time goes on? So genealogy is a very important part there. So we got to make sure that everything was done in conformance with the TC. And then, I've run into this one before: counterfeit parts and paperwork. I had a case one time where, in our system, a part and serial number, we had actually de-X'd it. It was no longer in the system. It could not be repaired. We had scrapped it, or so we thought. And a little over a year later, it actually came back into the system. And we obviously know that we have a problem here. And in the context of the industry today, we do know that there are counterfeit parts, and to compound it, there is counterfeit paperwork. So as you know, you need paperwork, and now you can actually bill. So these are the kind of things that cause issues, and these are the kind of things that need solutions. So there are some key takeaways that I want you to have today. I do want you to try to understand that blockchain can provide that immutable or that unchangeable part genealogy that you're looking about. So if you think about origin all the way through to a time when a part is not repairable, we can actually show that information. And of course, this would go from managing in minutes to managing in years, but the part genealogy is there. The cool thing about it is at the end of the day, as you set up these networks and as you start your tracking, you actually get a very time-phased look at the inventory. And when we talk about infusing trust, you know, this is beyond an approved supplier. There is a trust that comes from sharing data and exposing data and being transparent with data. It really offers a whole new look for you to take a look at your network and how you work with suppliers and how suppliers work with their OEMs. And the other thing about authenticity that's very important is not only do I have a physical part, but I have the paperwork that goes with it. And as we know, as supply chain leaders in aerospace, you have to have the part, you have to have the 8130, or you need the CFC so that you can actually use that. We was working and talking with a client down in Little Rock, you know, and this was a very interesting issue that they were having, because as soon as we started talking about the issue of the part and the paperwork and keeping those things married, I just had to start chuckling, because I've lived that same issue in my life as well. So let's talk about how blockchain and its infrastructure can actually help you build confidence. So first and foremost, this is non-technical. So I want to make sure everybody understands that. So what do I mean by non-technical? That means we're not going to have system designs and diagrams that we take a look at. We're not going to have architecture that we look at. But if you really want to see what some of this architecture looks like, you can surely go to Microsoft Azure blockchain, and they'll give you some basic diagrams, and you can start getting an understanding of that. We're not going to start talking a whole lot about cryptology, even though it'll creep into the conversation in a few places. So really not trying to get real technical with what we're doing. So please don't send me an email later and say, hey, a token is a lot more than just simply granting rights. Okay, I get it, but we're not going to go there. But one of the first terms that I really want you to try to understand is this term decentralization. It's very, very important. If we think about centralized data, it is your system of record that you use today. And it's your record, and you see it, and everybody in your company sees it, but nobody else does. What decentralization does is it creates data repositories that's out in many places. And the main part to understand about this decentralization is that it gets updated instantaneously. So if you make a shipment record, and we'll use that in a few cases today as we take a look at it, you know, if you have a shipment record and you make that shipment, everybody that's in that decentralized network is going to see that shipment all at the same time. In other words, it brings that visibility to bear very quickly. So the other term, when you start thinking about decentralization, so now we're talking about all of the players that you want in this network is decentralized. So all of the information is not in one place anymore. We want to talk about this thing called a node. And now it gets to the technical side of what actually creates the blockchain. Well, it's a node. A node is nothing more than a location. So you will probably somewhere in the near future, as blockchain becomes more and more prevalent, you will find out that you need to be a node for some blockchain. And it's probably occasion as blockchain becomes more prolific and used, you may become a node in multiple blockchains. So a node, just think about it as a place, and where I'm working at is my place. We have a node here in the blockchain. And distributed ledger is really an important concept. And think about it as the two words. When we think about a ledger, we can think about data and the way data is stored in any of our systems. Use SAP, for example. You do a transaction and that data record gets stored. So we have a ledger that's out there. The goodness of this particular ledger and what makes blockchain a bit unique is that record storage is distributed amongst every node that's in the blockchain. So we're going to have locations, and in those locations, we have this thing called a distributed ledger. And those ledgers are where we actually keep the records. And then you have this thing called a token. And this is where the crypto starts to creep into this thing quite a bit. But a token is simply code that's been written that grants you rights. It says your IP or your node, your location has a key to do transactions within this distributed ledger. So you have a location, you've got a ledger, now you have access to it. So now what do? Well, now we start pushing those transactions with that information to the system that we want, and we do that via this thing called a hash. And you'll understand hash basically to understand that it is a digital fingerprint. That hash makes anything and everything that you do inside of that network, inside of that blockchain, it makes it unique. It is encrypted, and there's a whole string of things on the front end, and that's where this term hash comes from. So technically, we don't have to understand the hash. Technically, we don't have to really understand how a hash works. All we need to know, it's a string of code, and that string of code makes that unique transaction seen and visible. And at the end of the day, that last little word down there, immutable, unchangeable, in the context of the blockchain. And that's the beauty of blockchain. Since this is decentralized and since it is sequential, if anybody went in to break the chain, in other words, hacking or something of that nature, then it's easily seen because we don't have centralized data where there's only one place where somebody can go in and do something nefarious. Excuse me. Now that we've pushed the data out from a decentralized standpoint, now that same data resides in multiple places, and it makes it more difficult to change. Excuse me. So I wanted to try to walk you through an example to help you better understand what I've been talking about. So in this case, we basically have supplier A, supplier B, and supplier C. They build product, they ship it to warehouse number one. When it gets to warehouse number one, they will store it, and then they'll pick it and they'll send it off to the aircraft manufacturer, who will then instantiate those parts inside of the aircraft, and the aircraft gets built. So to understand centralization, if you take an entity like warehouse one has its own information system. It could be resulted of an ERP system. It could be a WMS. They could have a yard management system. They could be within the context of a manufacturing execution system. But the point of the matter is all of that information, everything that drives that warehouse is contained inside of that warehouse information system. And every one of these entities that we're looking at on the screen has their own information system. Now, one thing that we do know is that we have things like EDI, we have supplier portals, we have email, we have automated ways to trigger activities between suppliers and manufacturers and warehousing. So, we can send information, we need you to ship. We need you to ship this quantity. We need you to ship it on this date. They can grab that, they meaning a supplier could grab that information. They could authenticate that information and send it back in the context of a confirmation. So the point is, we do know that even with centralized systems, there are some touch points where these systems actually talk to each other. But the core of the information within those systems is definitely contained within those systems. So let's talk about decentralization and let's create a node within a trusted network. Sorry. So in this case, we set up the fabric of the blockchain, and in that fabric, we go in and we say, okay, each one of these places, these locations is actually going to be a node within the blockchain. And once we know that they're going to be a node, then the thing that we do is we actually connect all these. And this is one of the core beauties of the blockchain. Everyone is connected to everyone else. We'll keep it simple, but do understand that there are ways to have folks participate in a blockchain, but not full participation, meaning see all data. Those things are part of the setup. but we'll keep it simple. And in the case that we're looking at, we're going to try to get the concept across and make sure you understand that once you establish this decentralized network and you set up these nodes, then we've created, you know, that trusted network. These are the folks that we're going to share information with. So now let's create this distributed ledger. Now that we know where the locations are, we've established the nodes. Now we establish a distributed ledger within each one of those nodes. And it's important to look and see again that all of these are connected together. All of the information that's going to be pushed throughout these distributed ledgers will be all pushed the same in this case that we're talking about, and it's going to be instantaneous. So it begs the question, well, what data do I push to the distributed ledger? So at Surgere, we track assets, you know, and we can automate a lot of this work. But if you think about a supplier releases a work order, creates a part, puts that part in a warehouse, then they ship it. It goes to an aircraft manufacturer who's going to receive that part. They're going to pick it. They're going to go to assembly with it. The aircraft's going to get manufactured, and then it's going to ship, and then it's going to go to a customer, right? So if you think about those different aspects and that genealogy that just occurred, then you have to think about the corresponding data. Now, this is just some representative data that we put in here, but the point of the matter is you have to determine what that data is, what data is important. You know, obviously, you need to determine that information. We're going to create data, but the other side of it is we're also going to capture data. And once we create it and we capture it, then of course we fuse it. And then we determine what of that gets pushed to the blockchain. So in the case of a part that you just built, you know, from shipping to receiving to assembling, and then you put it on the airframe, it had 0 hours on that part. And then as soon as it went on the airframe and started flying, we started putting hours on that part. So that would be a case where we would capture data and then we would fuse that data. And then if we could decide if that data needed to be pushed to the blockchain, we wanted an immutable record of everything that happened so that not only us, but also the supplier could see the hours that's being put on this particular part. So you build out the network, and the thing is, you don't build it all at one time. You start at a point and then you go through a logical build. And one other important aspect to understand, if you think about the distributed data, it's not the sum of all your centralized data, right? So you've got your massive systems with massive amounts of information in them. What you want to do is feed the right information to the blockchain. So the blockchain is not a replication of centralized data. It is just a representation of the data that you say needs to be secured and needs to be immutable to solve some type of provenance or genealogy concern that you may have. So the point is we have created the nodes, we've established these things called distributed ledgers, we've looked at the data that needs to be configured, we configure that, and then we grant access by this thing called a token. And the token itself, again, it gives you the ability to perform the work that needs to be performed inside of the blockchain. And the other side of it is it could actually limit your access to what you can do in the blockchain. But at the end of the day, that token is your cryptographic address. And that's what allows you to do work in the blockchain. Again, it gets back to that trust factor. We know who's doing the work. So let's think about what happened when we get a hashtag. We've got the whole system set up. Now something needs to occur. So we're going to use an example down in supplier C. Supplier C releases a work order to manufacture a part. They pick the parts, they go to operation 10, they perform the work, they complete operation 10, they move it to operation 20, more work occurs, more parts are applied. And at the time this is happening, we are pushing data to the blockchain so that we can see this transformation occurring. It doesn't have to be every part. It doesn't have to be every operation. It's just the ones that you determine need to be track from a genealogy standpoint. And then we go to operation 30, everything's fine with the part. We go to operation 900, quality comes in, they do the checks of the part, they run it, they test it, and then they say, yep, it's good. And then 8130 gets applied to that part, or a certificate of conformity gets applied to a lot of parts. So now we have this part, we've taken that 8130 and we said, hey, that 8130 is important. So we got this part number, serial number, this is the 8130 for it. Let's put this thing in the blockchain so that it's an immutable record. So we do that, and then we get that order to make that shipment. So supplier C is going to make that shipment, and it's going to do that transaction to go to warehouse 1. The thing that I want you to notice is that blue hash that just hit every distributed ledger. Everyone in that network just saw the shipment occur. They could also see the building of the part, but they just saw that shipment occur, and everybody saw the same information at the same time. Now, obviously, we could apply devices to the truck. We could track it through transit to know if it's between supplier C and warehouse 1. But the other next key point is we get to warehouse number 1 and we do the receipt, and you see this purple hash. So warehouse 1 has the token, they can get in there, we get the transaction and we do the receipt. And now we have the corresponding receipt that went with the shipment. So what everybody is able to see at the exact same time that's in the network is that the part shipped, and then they all saw that the part received. They understand it. And the goodness is, especially back to my days when I was the guy inside of the supply chain trying to figure out where are my parts and do I have my stuff. If you're that aircraft manufacturer, it was real nice to have that information come over to you. So I can take a look at the blockchain and I can actually see what occurred in this blockchain. I can see that the transactions have happened. I can see all the immutable records. Typically what happens at the manufacturer, you're calling the warehouse and you're asking the warehouse, hey, did you receive this part? And they'll go, well, I didn't see it in the system. And you go, well, no, I looked, I didn't see it. Can you check the doc? All of these kind of things that we do, then we're out calling supplier C and asking them, did they make the shipment? What blockchain allows us to do is to put this data together and fuse this data together so that we're able to see all of this very instantaneously. So if we think about what just happened with this example of a blockchain being used in the aerospace industry, we did create provenance. We know that the origin of a part was established at supplier C because we pushed that information over to the blockchain. And as we built that part, we made it part of the data stream and we recorded all that in the ledger. So now that we have genealogy, the quality information, after the part is physically built, we know how it was built. We can even, through your MESs and different data systems that you use, you can say who built it and how they built it. But it's important at the end of the day that we can attach the quality information to it. And we can create that immutable record that says this part, this serial number, and this paperwork is always linked together. So that when that shipment goes from supplier C to warehouse 1, supplier C knows that everything it takes for the aircraft manufacturer to use that part is with it. And back to a point I was making earlier with a problem I've had before, I physically have the part, but somehow the paperwork got divorced from it. And I don't know where the paperwork is. I can go back to this immutable record and I can recapture paperwork and I can make that marriage occur. Of course, we have to go through quality and those type things. We do things to our processes. But the other thing to get in mind is the network just saw supplier C make that shipment to the warehouse, and they saw that it was received by the warehouse. And that's powerful, when you're in manufacturing. Genealogy was created then throughout the whole supply chain. So again, it's about what you need to solve for and how wide and how deep and how much data do you want to push to the supply chain to keep. But if you really want to tighten yourself up, we look at this too to solve problems for recalls and things like that in the automotive industry. So there's a lot of application here for why blockchain may be a smart move. But this is one of the other key things. And as a supply chain professional, I'll date myself. I got my CPIM back in the 1980s. Okay. One of the things that we were trying to learn and do back in those days was this thing called synchronization, or synchronizing part and information flow. And I've spent 30 plus years trying to figure out exactly how to make that happen. I've done the JITs, I've done the Kanbans, I've played with every system imaginable, you know, really trying to sync up information and the part. And the part always gets there before the information, or the information typically gets there before the part. There's no real synchronization. So this is one of those things for supply chain professionals that this should be like aha moment. This blockchain technology is the technology that enables the synchronization of part and information flow. So it's only been 30 years coming, but it's exciting to me to see that we have something like this. So obviously, you know, a lot of the key buzzwords out there today is between ML and AI, right? If you think about the context of what we just talked about, if we think about the context of the instantaneous ability to see what's going on in the supply chain, can you imagine what you can do with machine learning and artificial intelligence now? That you got accurate data to work off of, and you've got time phase data that you can deal with. Just go back to the very simple things. And this is one of the things where it really was making my mind work. If I was that aircraft manufacturer and I had a lead time of 20 weeks built in for a part to get manufactured and shipped to me for a ship set to go on an aircraft. If I'm 18 weeks out and my supplier hasn't released a work order yet, then why not? Again, here's where I can set up analytics, I can set up business rules, and I can start asking the questions sooner. And what I may find out through machine learning and artificial intelligence is that they never take 20 weeks to build that part. It takes them 13 weeks to build that part. Then why don't I get my system correct? So if I think about what does that fundamentally mean? So there's 7 weeks of MRP action messages that nobody has to play with. So again, there's a whole world out there for the supply chain professional to really start digging into the data. And again, as you expose this data and you see the transparency of the data, it will make you and force you to work differently with your suppliers and your supply base. So for me, blockchain is one of those things where I wished I would have had it 20 years ago. I can only imagine some of the things that I probably could have accomplished if I would have had it. So if you just sit and think about what can I do with end-to-end visibility with synchronized information. And at the end of the day, you know, if I think about this genealogy, I've created a trusted network and I've built a way to work with suppliers and suppliers with their customers in different ways. So, you know, talk a couple minutes here about Surgere and what we do. So Surgere, we are an IoT device company. We track assets, we track objects. You tell us what the object is, whether it's a part, whether it's a container, could be tooling, we can track it. We can basically tell you where it's at. We use different type sensors. We use different type devices. It just depends on the problem we're trying to solve. And then at the end of the day, we push all this into our Interius software. And Interius is nothing more than a Greek word, a Latin word that basically means inside. So if you want to see what's going on inside your supply chain, that's kind of where we shine. Our software is not built where you buy the whole thing and you have to pay for a bunch of stuff you never use. It's broke out in small modules. And these modules, you get what you need to solve any particular problem. So we pick and choose. One of the cool things about it, you know, for those of you that are Microsoft users, you can see over to the right, there's a Power BI. You know, we use off the shelf stuff. But the other cool thing about it, you can also see that, we can also not just give you the view of your asset within the software, we can also show you the hash. We can show you the blockchain and show you that immutable record of something that occurred. So for us, it was really neat to take the IoT side of this, where we always focus on accuracy and then build the blockchain into it. So now we get the authenticity. So accuracy and authenticity is the thing that we try to push. And at the end of the day, we built all this on Microsoft Azure. Y'all know the security measures around that. I will make the quick note too, if you work in defense or you have FedRAMP obligations or you have to be ITAR compliant, whether you're the licensee or we have to sub-license, basically we have partnered with DXC so that we can host the application on their approved FedRAMP and ITAR servers. They went through the 417 odd questions or whatever that is in FedRAMP, and they've got the check marks, and we love them. So if you need that type of structure, you need that type of security to work in .gov, then just let us know. We can play there. So kind of getting close to wrapping up here, accuracy and authenticity. You talk about speed and precision. If you can take the accuracy of what's going on with the IoT, and we know what that accuracy is, and we drive the blockchain with it, speed and precision, it's there, it's right. So that helps you in your production. IoT obviously brings a peace of mind from our perspective, because beyond immediacy and transparency, we really focus an awful lot on ease of use. What good is a system that's highly complex that people can't actually use the thing? So from our construct, we build and do all the complex stuff on the back end that people don't use and look at. But on the UI side, we make it very easy to make that shipment, to make that receipt, to track that work order as it runs through manufacturing. And we know that it's important for ease of use to be part of this, simply because adoption. At the end of the day, people have to use the system. And that's one of the cool things as people start talking about Industry 5.0, even though we've not really digested 4.0 too well. But 5.0 is really the putting of the human back into the thinking of this thing. But at our core and at our heart, they've never left. They've always been there. How do we make things that are very easy to use, that are very repeatable and are very reliable? So that's kind of where we focus the use of our software. You can learn more, about things that we see going on in this post-COVID world. You can go to surgere.com, go into aerospace, and you can see that white paper down in there. But with that, I will say thank you. I know that was a good bit of information, but I hope it was simple enough to digest, and we'll open it up for questions.
Great, thank you. Thank you, Rusty. We had a few questions come in from Phil Menard from the International Trade Administration. I will ask the first one here, and then we'll see if anybody else has a question that they want to just ask directly. And if not, we can go back to Phil's questions. So the first one is, he says, I understood that blockchain can be used to transfer payments. Where do the banks come into this scenario?
Must have missed that first part about, we're not talking about cryptocurrency. I honestly am not even going to try to answer that question. Where does the bank come into this thing? Because I have actually done an awful lot of reading on cryptocurrency. Unfortunately for me, if you scroll back a year or two, when it came to blockchain, if you learn anything about it, it was all about cryptocurrency and how it was going to be used. And one of the core issues is basically with cryptocurrency, you don't have to have a bank. You actually can go around a bank. So that is the kind of thing that really takes some study, and it takes some expertise to really explain. And I don't have that expertise. So I think in one way, I will sort of answer the question by saying you honestly don't have to have a bank, and that's the core problem. The other side of this thing is, as you know, and you read the news like I do, banks are getting involved and governments are getting involved, and they're starting to prop up different Bitcoin models so that they can actually perform these transactions and get into the point of regulating it. Sorry for that answer, but that's the best I can give you.
That's okay. Do we have anybody that has a question that they'd like to ask directly right now? You can just unmute yourself and go ahead.
Hey, Stephen, this is Chuck Baker.
Hey, Chuck.
Hey, Joe.
Question I have for Rusty. How does a company, I run a company outside, everything else, and I want to be able to supply something to an aircraft company. How do I get involved with blockchain in the first place?
So obviously, there's a couple of ways to take a look at it. One is you can create nodes of yourself. You can set up a blockchain. You can set up a blockchain internally that starts writing what you do in your manufacturing facility to an immutable record. So now you have the difficult thing of talking with your aircraft supplier, or I mean your aircraft client, to talk about how can we share and use blockchain together. How can, I think there has to be something in it for them. If I was the aircraft manufacturer, and that's where I was not too many years ago, I would love to be able to work with you and be able to see what you're doing and how things are progressing inside of the factory as I'm trying to make sure I have all the ship sets that I need to build. So I think you start, again, you have to start at a local point and you have to push out from it. And if you can get a pilot case going with one of your aircraft manufacturers, again, it's about packaging the message that makes it inviting for them to be able to see what's going on. Because as a supplier as well, especially in the aircraft world, I would want to know where and how my product was being used at an aircraft manufacturer. I would like to know and make sure I understand the airframe that it's on, because at the end of the day, you understand and know the liabilities that you have with the product that you built. So again, this blockchain helps build out those records that you can keep for perpetuity, and you have confidence in how you built it and how you delivered it to that aircraft manufacturer. So I hope that gives you some understanding, Chuck.
Yeah, I appreciate it, Rusty. Thank you.
Hey, Rusty. Kim Christ here, Director of SE Tech. Curious, when you're working with your vendors, what type of resistance you're seeing to blockchain, if any, and if you are having any issues with comprehension of the technology using the interfaces that you all provide. What type of training is involved in that?
Yeah. So we might need to go back. Yeah. So the first thing to think about is, what are we seeing? It's interesting. I was talking to a guy who's done an awful lot of work with blockchain in a different company, and we were talking it through, and we keep running into this problem. Anytime you mention the word blockchain, half the room just got excited because they think it's something that might can help them. The other half of the room just got, oh gosh, not another toy, to look at and play with, or I don't think it's ready yet. So you have the whole gambit of attitudes when you actually start talking about blockchain. There is one thing that I also have learned is, number one, from a very technical standpoint. Actually, I was a crypto guy many years ago when I was in the Army. So I do understand cryptology, but I don't technically try to understand everything that's going on in the way that the architecture is built for blockchain. So you have to really break the conversation out into two conversations. You have to have a practical conversation that says, this is blockchain, and when you use it this way, this is what you get from it. And by the way, we all see it and it's immutable. And people can get their head wrapped around it. However, you have the technical side of this thing. when you sit there and you start building out all these little widgets and things that have to go together to make this work. At the end of the day, there is one thing that most people can understand between the practical side and between the technical side. At the end of the day, it's still all managed with APIs, and everybody understands how we can take data from point A and get it over into point B and what happens with it when it occurs. So in some ways, Kim, what we have to actually do is divorce the conversation of the technical side with the practical side, because quite honestly, there's not that many people that can really sit there and mesh the two things together and really understand it well. So for us, it's about sticking with the practical side. Oh, we want to have a technical conversation. I don't try to get into how many hexas are in a hexadecimal. I don't have a clue. I've got really smart people that I can bring into the room, and I'll let them do the technical stuff. That being said, we are very, very integrated with Microsoft. Microsoft, we're one of 26 IoT providers. So at the end of the day, when we need to, we bring Microsoft into the room, and they're willing to come with us and work with us in anything we got going on. So it's it really is, in simple terms, we keep the practical and the technical discussions kind of in their lanes and try to keep it that way. Hope that answers your question, Kim.
Yeah, Rusty, that was great actually, because working in tech, I find that even those of us who are technologists, don't always understand the intricacies of blockchain. I think this is a fantastic application of blockchain that's, separate from the crypto side that is very applicable to South Carolina industry. I appreciate all of your insights today.
Oh, thank you. Okay, any more, Stephen?
I can go back to the questions from Phil. We had, can accounting use blockchain to identify country of origin of all the components and assemblies they receive from their suppliers?
So the basic answer is yes, of course. It's data, right? So if there is, first and foremost, as you establish the blockchain, you need to establish the need for that record, okay? Which means that record has to be posted somewhere. So at the country of origin, if it's in your paperwork, if it's at the supplier that's actually building, that's part of that trusted network, then you can automatically post that or country of origin inside the record itself. So the basic answer is yes. The other side of it is we know complexities with that. Obviously, you would not grant a token or the ability to affect your blockchain if you didn't already have some way to validate that this was your source. And if you can't validate the source, then I would not corrupt my blockchain with errant records, if that helps in understanding.
Sure. Well, we'll have one last call here for any questions that anybody has.
Okay, one more, Stephen. This is Chuck Baker again.
Go ahead.
8130s. I've dealt with 8130s when in supplying aircraft tires to the aircraft manufacturers. But once in a while, you'll lose that paperwork, which is a pain in the tail, and you have to recreate the 8130. Yep. Rusty, do you see any time in the future there's a possibility of actually eliminating 8130 and go 100% blockchain?
Boy, that's one of those, I certainly hope so. I do think that from a regulatory side, it's a little bit slower to keep up with where technology is actually going. I think also, I've actually talked to a guy that is using 8130s and pushing them to a blockchain. So that the goodness is you can always go back and pull that 8130 and relink it. The issue that I used to have, just trying to, again, be practical, is I've got a part, it's still in its original box, it's never been opened, and the 8130, well, it must be inside. Well, let's open it and see. No, there is no paperwork. So I've got this part and I don't have an 8130. So I can go back to the manufacturer, I can try to get an 8130. As you know, in most cases, a lot of times what they would basically tell us is, no, send that part back. We got to revalidate it. We got to make sure that you guys didn't do something with it. So you have the practical side of this. You're going to have to catch up from a regulatory standpoint, and you're going to have to catch up internally from a quality standpoint to make sure that you have confidence that that 8130 is now being married up to that part, that lost 8130 is now remarried to that part, and that part's condition of supply is conducive to go on the aircraft. That's one thing you never get away from. It's always there. But I do believe that the government is making a lot of headway in trying to secure. You'll have these other things, especially when you get defense related with CMMC and all these requirements that are coming out from crypto security. You know, they understand too that blockchain is very, very secure at the end of the day. So there's a lot of work that's going on. We have clients that's talking to us to use blockchain to solve their CMMC problems. So it's definitely something that's coming. It's something that I think will be adopted. And I think it's something that the more we get into it and the more that the government sees that we have a way to control it, they will be very pleasantly surprised in the way that we use it.
Appreciate it.
Russ, got a question for Rusty.
Okay.
If I may. Rusty, are y'all doing anything with additive manufacturing and, to increase, the, or try to shorten the steps of manufacturing that incorporates blockchain?
No, actually, we are not. So we're not into additive manufacturing from the standpoint, we don't make devices that can transform material. What we do is you buy the stuff, you do the additive manufacturing, and if you want to create the blockchain to track that data, that's where we can help you. So, we can help you with the data side of it, but we do not do any manufacturing at all. We are a purely technology company.
Would you be interested in some linking up with some folks that are doing that?
So is there interest in hooking up with some folks? Yes, there always is. I love cutting oil in the morning, so I love manufacturing. So yes, I'd be glad to talk with anyone.
Terrific.
And I'm sure there's possibilities.
I'll be in touch.
All right. That's great, Dennis. Thank you.
Very well. Last call here. All right, hearing no more questions, I think we're going to wrap up. I would just like to again thank Rusty for the presentation today and Surgere for their support of SC Aerospace as our newest partner. And Rusty, I know we got some immediate good feedback. I got a note sent over from Steve Schellenberg, a consultant at GSP Airport, saying, "Hey, I'm looking forward to this being posted online because I want to send it out to my staff because this is good information I want them to hear." So yeah. Thanks again for all this, Rusty. And we will be following up with, we'll have a follow-up email with the link to the recording that anybody would like to share if you'd like to go back and watch it again. We also had a question about the link to the white paper, so we'll be sure to include that. And Rusty, I think we can probably include your contact information if anybody wants to follow up directly with you. But thanks again, Rusty, and thank you everybody for signing in today.
All right, I thank y'all. Have a great day.
Take care, everybody.
Yep. Bye-bye.